Hello and welcome back. In the last episode, we added our particles so they can move a little bit around in our world. And in this episode, we will implement our neighbor search. Alright, then let's jump to Visual Studio and add a new file. And this will be called fluid hash grid. So let's do that. Fluid hash grid.js. All right. And here I'm going to create a new class, fluid hash grid, with a constructor. And here we pass our cell size. And of course, I need to turn off GitHub Autopilot. I always forget that. All right. And now we can set cell size to the given cell size. We also setting the hash map or initializing the hash map. And in JavaScript, it's just a map. In C# or in Java, it's a dictionary, I guess. And I think in some languages it's a set, but I'm not sure, depending on your language. And then we have the hash map size. This hash map size should be at least larger than the amount of cells you have in your simulation. But I'm just going every time with a really, really large number. What's that for a number? Like 10 million. And then I have my prime numbers. These are the same prime numbers I had in the previous video. So the first one is this one. Just copy this. 8611, is that right? 66140586, yeah, that's correct. And then the prime 2 number, this is the 752-885-0467. All right, and then I have a particle array, particles, which is empty. Okay, then I have a initialize method, and this initialize method just takes the particles or the particle array. It's we just want to connect the particles array with this reference. So every time the simulation adds a new particle, it's automatically added in the fluid hash grid. So it's basically the same array like in the simulation. Then I have a method clear grid. Oops. And here I'm gonna clear my hash map. All right. Then we have the first method, which is, well, really, really important. And that's the first step to get a hash value. And this is the grid ID conversion step. That means we get a position from a particle and convert that to a grid index. And I'm going to call this method grid ID, get grid ID from position. Yeah, from pos. And here I have a position. This will be a vector. And then I can convert the position by using parse int. I'm going to parse it to an integer. Or if you're in C# or in Java, you can use just this one. yeah, I'm gonna parse it to an integer, and here I'm taking the x component divided by this cell size. Right, and I'm gonna do the same thing for the y position. If you do it in 3-dimension, then of course you need to do it for the z component too. All right, so that's our grid ID. And now I would like to call a new method, but I have to create that first. So let's create that. And this is our step from converting the grid ID to a hash value. And this is the, well, I call it cell index to hash. You can also call it grid index. It's also fine. And here I get, all right, I'm passing a x and a y for the grid index. And here I'm gonna calculate the hash, and this is now x times list.prime1 with a bitwise XOR operation with y times list.prime2. All right, and then I'm gonna take the modulo, and this ensures that we are not getting out of the array size. Well, out of the hash map size. For example, if you do that on, if you do it in a compute shader, for example in Unity, where you don't have a map, for example, then you can use classical arrays, a really, really large array, and this modulo just makes sure that you don't get a out of bounds error or something like this. All right, and then we can return the hash. And I'm gonna call this method right here. And I'm saying return list.cell index to hash. Okay, and I'm gonna pass the x and the y values, and there we go. Now, I'm gonna create the map particles to cell. So map particles to cell. And here I'm gonna take the whole array and do the whole process of assigning a particle to the map. All right. So for this, we need to iterate through every particle. Okay. Then I'm gonna get the position of a particle. Position, there we go. Then I retrieve the x value from the grid index. Actually, I think we can just use this method here, so I'm gonna skip this one. I would just do the same thing what we did here in the grid index from position, and then calling the cell index to hash. So instead, I can just skip this step and say let hash is equal to get grid ID from position. All right. Maybe this name is a little bit confusing because this indicates that we're getting a grid index, which this one is actually a grid index, but we're returning a hash. So I think I would say I'm gonna convert this to get grid hash from position and not get grid ID from position. I will instead copy this method and do that right there, and I'm gonna return these two values. I think I'm just gonna do this, and then I'm not quite sure. Yeah, I think like this one. Yeah, now I have the get-grid ID from position 2. Actually, I think I'm just gonna return a vector. In JavaScript, I guess it's not really important which data type it is. If you are in C# or in whatever other language, then you might need to do that in another way. But I don't think even we don't need that. All right, so then let's jump back to the map particles to cell. Now I'm retrieving all the contents from a cell or from the hash key. We can do that by calling this.hashmap.get hash. And if the content of a cell is already, well, isn't there, so that's the first time we are accessing a cell, this means that the entries will be null. Then we are creating a new array inside this key. And we can do that by saying new array. Oh, new array equal to a new array. That's the JavaScript type of creating a new array. And we can already parse the first particle, and this is then this one. All right, and then we still have to set this value at this key position. We can do this with this.hashmap set, then at the hash key and with the value. All right, and if there already is a entry, then we just say entries.push with this.particles. Later we will improve our algorithm where we just instead here we take the whole object of a particle. Later we will change that to just indices, but this will be something for a future episode. All right, and that's everything for our map particles to cell. You know what? I'm just gonna remove this function again. Sorry. Yeah, and then I have one last method, and this is the get content of cell. So get content of cell. This method just returns all the content of one cell. And I think we could use it maybe like right there. I'm not sure. Well, anyways, here I'm saying the content is list.hashmap. Get by the ID, so we're passing the hash ID from the get content parameters. And if the content is null, that means there's no entry, we just return an empty array. And if it's not null, then we return the content. All right, and that's everything for now for our fluid hash grid. As I said, we will improve this class later on. All right, so let's jump to the simulation class. And here we need to add this new class to the parameters or to the attributes. And I'm saying here this dot fluid hash grid is equal to a new fluid hash grid with a cell size of 25. I'm using 25. You can, of course, use something else. Then I need to initialize the fluid hash grid. So this dot fluid hash grid initialize with this dot particles. All right, and then we still need to call the fluid hash grid for updating. And I think I'm not quite sure where I'm gonna put that. I think I'm gonna create a new method here, and I'm gonna call this neighbour-search. And just for this episode, and maybe for the next one, I pass a mouse position so we can see our neighbors. And this will then be this dot fluid hash grid dot clear grid. Then we call this dot fluid hash grid map particles to cell. And now I'm gonna get the contents of a cell from the mouse position, so we can actually see our particles around our mouse position. We can do that by saying grid hash ID is this dot fluid hash grid get grid hash from position, and this is just the mouse position. Then we can also retrieve the content. We need the content, we need that method, and later for getting our neighbors. But for now, I just want to get all the particles in our same cell. So fluid hash grid get content of cell. This is the grid hash ID. And then I'm iterating through every particle from that cell. Well, actually, I'm gonna reset first the color, because I want to colorize all the particles in our cell. So let's do that first. Just the particles. Color is 28 V0FF. All right, and then I'm just gonna copy this for loop again, paste it in here, copy the content of cell, and iterate all. And I'm gonna iterate over all the content. Here I'm saying the particle is the content of cell at this position. And now I'm just saying particle.color is, let's say, orange without the hashtag. There we go. All right, then we still need to add this file to our main HTML. All right. And then in simulation again, I'm gonna pass the mouse position through the update. I also need to call the neighbor search. So let's do that first. Let's call our neighbor search. Here I'm gonna pass the mouse position with as a parameter, and I'm just doing this for this episode and for the next one, just to see that there is some neighbors around our mouse position. And we need to pass that in the playground.js. And here I'm gonna say this dot mouse position, and of course I need to create this variable too. So this dot mouse position is equal to vector 2.0, I think. Yep, there we go. 0. And then at the on mouse move, I'm gonna say this dot mouse is equal to position, or Oh, I actually pass still the X and the Y. I don't want that. I'm changing this to position. I'm gonna pass the position here, and of course I need to change in the HTML file the position. This is right there. Oh, I did that right here. Oh, that's funny. Okay. And I think now we have everything to try it out if it's working. All right. Okay, and what I forgot in the fluid hash grid is we need to pass the position here. I don't know how this is happening all the time that I forget to pass something. And now I guess we can jump to our browser. So refresh and save. And now go to the browser, and as you can see, we have our neighbor search working. I'm gonna disable the movement, or I'm just gonna say that the particles should not move anymore, so I'm not setting a velocity right there. So go back to browser, refresh, and now we have our rectangle of particles, and here you can see our neighbor particles from our mouse. Of course, it's not gonna get every time all the neighbors, like this example right there. Oh, you can't see my mouse. Oh, all right, that's a little bit problematic. 1 second, where can I set that? All right, so now you should see my mouse. There we go. And as you can see here, the mouse position is over this under particle, but it's not showing as a neighbor. And we're gonna solve this later when we are also getting the neighbor cells. All right, that's everything for this episode. In the next episode, we will add the neighbor cells too. And then we have everything set up for our main algorithm to implement the fluid simulation, or let's say the first step to get a running fluid simulation. All right, thank you very much for watching, and see you in the next episode.